I'll pause it. Okay, so the central angle of a circle is an angle whose vertex is in the center of the circle. So if this is my circle, angle ABC is a central angle. This angle here is the central angle. Okay, its vertex is the center of the circle. Yes, you do. I don't care. Do it again. So with the central angle comes certain arcs. So there's a minor arc, a semicircle, and a major arc. A minor arc is any arc that is less than 180 degrees. And we usually label it using just 2 letters. And you'll see in a second how we do that. So, anything less than 180 is considered a minor arc. Normally with angles, like acute was 90, right? And obtuse was over 90. With circles, because we now have 360 degrees, the 180 is to cut in half. So if you have a circle and you have an angle like we just did, they'll give you like 2 points on the circle. Let's say A, B again. The way that they write a minor arc is they do A, B with like a little arc on top. And that's the measure in degrees from here to here. Okay, so it's not the length. It's not like in inches or centimeters or whatever. It's just in degrees. Like that could be 40 degrees. Okay, that would be a minor arc. 50 degrees, 60 degrees, whatever. A semicircle is how many degrees you think? 180. Any arc that is exactly 180 degrees. So it's half the circle. And usually, so they'll give you a circle and there'll be a bunch of points on it. If I'm looking at a semicircle, here it would be arc ABC. So sometimes they'll use 2 letters, sometimes they'll use 3 letters. They use 3 letters because that's the order it's going, just like with an angle. So if I'm looking at arc ABC, I start at A, I go to B to C. So that would be a semicircle. That's 180 degrees. And you can usually tell because there's usually a line, like a diameter in there. So if minor arc is anything less than 180, semicircle is 180, major arc is anything over 180. So any arc that is more than 180 degrees. And usually for a major arc, it's written with 3 letters. They'll use 3 letters, 2 letters for minor, 3 for major. So again, you have your circle. I could name this arc, this major arc, all the way around. I could name that 2 different things. I could name that ABC with an arc on top, or CBA with an arc on top. Okay, so remember how in like chapter 1 we had, if it's a segment, it's just a little line. If there's a line symbol, now we have an arc symbol. So those are the 4 things you need to know today for arc measures. We're going to get into different ones on Friday that are a little bit more complicated. So when you're measuring arcs, the first thing you need to know is how many degrees do you think a whole circle is? 360 degrees. Whole circle is 360 degrees. So the measure of a minor arc is always the measure of its central angle. Bless you. And minor arcs are always less than 180 degrees. So for example, see how it says MAD with the arc on top? That's the measure of arc AD. So see how it got kind of cut off, but see how there's a 50 degrees? That's the central angle. Think of it as it's shining a light on DA, or AD, this arc here. So this is also 50 degrees. Does that make sense? Think about like flashlight. So the measure of arc AD is 50 degrees. A major arc is the difference between 360 degrees and its related minor arc. Major arcs are always more than 180 degrees. So if I'm looking at my circle there and I want the measure of arc ABD, you go in order. That goes A all the way to B, all the way to D. So how big do you think that whole part of the circle is? 3 what? Because you take 360, subtract the 50, and you get 310. Okay. The measure of a semicircle is 180 degrees. So A to D to B, A to D to B. You don't have to have as many highlighters as I do. A to D to B, because it cuts through the diameter, is 180 degrees. Okay. So let's try just naming some arcs. Because you won't always have to find the angles. Let's just try naming them. So number 1, name the arc shown in bold. Tell whether the arc is a major arc, minor arc, or semicircle. So this guy right here, how would you label that? Yeah, just AB with the arc on top. Is that a major arc, a minor arc, or a semicircle? Minor, because it looks like it's less than 180 degrees. What about B, this bolded guy? 2 ways to name him. A, say it again. ADB. Good, or BDA. And you can't just do AB, because AB, people are going to assume it's the little guy again. Major arc, minor arc, semicircle. Good. And then this last bolded one, again, 2 ways to name it. What do we think? QSP, PSQ. Major arc, minor arc, semicircle. Okay. Now let's try and figure out actual angle measures, arc measures. So here, find the measure of each arc in circle C, where AB is a diameter. Also tell whether the arc is a major arc, minor arc, or a semicircle. So here, the same rules apply in circles that applied like to just normal life. If this is well, we'll get there. How big do you think is arc DB? Just from D to B. Look at its central angle. So it's always the same as its central angle. So if this is 135, D to B is also 135, which makes that a minor arc. D to A to B, there's actually different ways to find D to A to B. You could do, if it's the pink, 360 minus 135. Which gives me 225. Or we could think about this side here is 180 degrees. How big do you think this little angle is? Can I figure it out? What is, if AB is a diameter and makes a straight line, how many degrees does it have to make total? 180. So you can take 180 minus 135 and get 45 degrees. So anything that you learned in chapter 3 about angles also applies here. Oh, this is a major arc. And then A to D to B is what? Last one. Semicircle. And that's 180 degrees. Okay, so just like I just said, if two arcs in the same circle are adjacent, that means they have a common endpoint. So you have adjacent arcs if they have a common endpoint. In this diagram, arc AD and arc DB are adjacent arcs. AD and DB are adjacent arcs. And just like we did, what I did there, you have the arc addition postulate. We had angle addition postulate. We had segment addition postulate, both first semester. Now we have arc addition postulate. That basically says if two adjacent arcs are formed, you can use the sum to find the measure of the two arcs put together. So you can always add arcs together. They're always going to add up total, all of them, to 360. So here, arc, the measure of arc ABC would be the measure of arc AB plus the measure of arc BC. So you can take two little guys to make a bigger guy. Okay, today's not too bad. The regular arcs are not too bad. It's Friday when we get all the fanciness with central, inscribed, and circumscribed that gets tricky. So here's a picture, old school pie chart on Pi Day. So this is ages of people. This should be a T. This is a U, a V. I think everything else is pretty obvious. So we need to find all the different arc measures. Again, it's just whatever piece of the pie it has. So for A, if you want to find RU, because it's only two letters, is a minor arc. So it starts here and goes to here. RU. So how big do you think RU is? From here to here. Just add up what's, oh, you guys can't see it very well, but this is how big? 60 and 80. What does 60 and 80 add up to? $140. B says R to T. So that's from here to here, R to T. So how big's R to T? 130, because you add the 100 plus the 30. A lot of this you do not have to show work on. Okay, I'm just showing work because we're taking notes. The next two, you can kind of tell they're going to be bigger than 180 because there's already using 3 letters. So C says R to V all the way up to T. So add those 3 pieces of the pie together. What do you get? What's 60 plus 80 plus 90? (230 degrees). There's another way to find this, R to V to T. We could do 360 minus our 130. So there's multiple ways by either adding or subtracting to figure out the measure of the arc. And then U, now see, here's the tricky part. U to S to T, I want to just go this way. But U all the way around to S to T. So if I highlight that, it's kind of hard to highlight because once you highlight, you're done. U all the way to S to T. How big do you think that is? What is it? 270. You can either add up all 4 of these, or you can take 360 minus the 90. So you can either do 30 plus 100 plus 60 plus 80, or you can do 360 minus 90. Either way, you should get 270. So, like I said, a lot of this is just going to be right or wrong. Okay, when you do your homework tonight, a lot of it's just easy. Now, example 4 we got to do together because the picture is actually kind of tricky. So it says AC and BD are diameters of circle E. Find the measure of the given arcs if the measure of angle ACD is 316. Okay, so draw yourself a circle. And we're going to give ourselves 2 diameters. Kind of make like an X. Okay, ACD is going to be 316. So I'm going to make this A. This is D. This is C. This is B. So the only thing we know in this picture is A to C to D. That whole thing is 316 degrees. Before we even, well, so the first question says, how big is AD? How big is the little arc that's left over? Take 360 and minus 316. So you get AD is 44 degrees. Okay, that's how big that arc is. Just using those 2 things, you can find all the other information. If this is 44 degrees, how big do you think BC is? 44 degrees. Do you guys remember vertical angles? If this angle's 1, then this angle's the same one. Remember that from chapter 3? So that means BC is also 44 degrees. It's kind of like a vertical arc, even though there's no such thing. But if this angle is 44, then this angle is 44, which means that arc's 44. B to C all the way over to A. So actually, before we figure that out, let's figure out the other two sides. Can we figure out what these guys would be? What do all four angles have to add up to? 360. And you already have two of them. And you know DC and AB are going to have to be the same size because they're also a pair of vertical angles. So I'm going to cut this in half. So each side is 136. Okay, so the hardest part about this stuff is there's not like a lot of, it's not a process, it's just like kind of using your brain to kind of figure stuff out. So B to C all the way over to A would be all three of these parts. Okay, so or we can do 360 minus the 136. Either way, you get 224. So you think about it as 44 plus 136 plus 44. And then the last one is D to C to B. D to C to B would be 136 plus the 44, which is 180 degrees. Okay, so if they don't give you all the pieces like they did in example 3, you got to use your brain to figure out the missing pieces like we did in example 4. No, if it's a diameter, it's 180 degrees. You can still have vertical angles. Okay, and everything's got to add to 360. If you remember those three things, you can usually figure it all out. Okay, question?